And our next speaker is Wenbing from the Netflix MediaML team, and she will be explaining how they do MediaML and inferencing at Netflix. Thank you.
Hi, everyone. My name is Wenbing. Yeah, thank you for coming. So today I'm going to talk about MediaML infra and inference at Netflix. Actually, I feel great and relieved that we are building infrastructure that follow the rules John and Eric just mentioned. Yeah, so today I'm going to give some context about MediaML infrastructure team at Netflix, who we are and what we build. Later, I will use a viral search example to go through the infrastructure, including how we manage the media access, how we leverage Metaflow hosting to do the inference at scale, and also talking about the feature store and the integration with machine learning applications. I will do the Q&A last. So who we are, MediaML Infra team, we are part of MLP and Netflix. And our team builds media-focused ML infrastructure. The goal is to reduce the time from ideation to productization for our MediaML practitioners. So our MediaML practitioners at Netflix mainly help three business areas. They help with the content creators. They work on the machine learning models that will be used for internal tools to support the promotional content generation, for example, trailers, Instagram Reels, to assist localized subtitle creation, and to enhance the vision of creators, for example, visual effects, media quality control, and animation. Today, I will use trailer creation as an example to go through how machine learning and the infrastructure help here to achieve the business goal. So now, suppose you are going to create a trailer for an action movie, and you know you are going to use a shot of a car exploding. So video shot means changes in camera. And typically, the video shot duration is few seconds up to few minutes. As a creator, you definitely don't want to look for the car exploding shot by scrubbing the whole film. And maybe you have to take notes on different visual elements. Later on, if you have any new idea, you probably need to go through the film again. And for sure, you don't want to do this again and again every time a new title comes in. Imagine you could have a visual search engine which can help you find the right visual elements for the entire Netflix video catalog in a second. So how are we going to build it? This is the UI. Imagine there is a search bar and you can search, for example, car exploding, and the web application will return a page of video clips. And you can directly drag the clips into your trailer creator editor. Yeah, so machine learning for sure can help here. Yeah, let's start small. For example, you just need to do this for one movie, right? You probably want to segment your whole movie into video shots first. And then you probably want to use a NumPy array, present each video shot. We also call it embeddings. The embeddings contains the visual information of the video shots. And then you will need to store all the embeddings in a store. When the text query comes in, for example, the car exploding, you will extract the text embedding from the string, go to the video embedding store, do a nearest neighbor search. You will get the video shots related to car exploding. So here we simplify the video embedding store to a two-dimensional embedding space. At query time, the input text query can map into this embedding space, and we can return the closest matching video shots. So I will briefly talk about the algos behind the scene used to build this embedding space. We use contrastive learning, which works well for image and text pair. And we extend this contrastive learning for video and text pair, which provide an improvement on frame level models. On top of the video retrieval, we also have a couple of video clip classifiers within Netflix that are trained to find a particular attribute, for example, the caution elements. So we simplify the inference workflow to build the embedding space as this. So you have video segmentation, and then you put the video shots into the video embeddings to get the embeddings, and then fit into different binary classification algos. Now we can build an embedding space for the action movie you are target on. Then how to build a viewer search engine for all movies at Netflix. The scale challenges show in different aspects. For example, how to access the media assets. In our case, we use videos and text, and how you can find the right data format for your models. In addition, how to orchestrate the inference workflow at scale, and how to serve the inference results to machine learning applications. So machine learning infrastructure comes into picture to make sure the scaling is easier. So this is an overview of our MediaML infrastructure. There are 4 major components. On your left, you can see the blue boxes are media store. Actually, this provides the media access to machine learning practitioners. In the middle, the green boxes are the services that scale the model inference on media assets. And on your right, the red box is a feature store, a storage layer where we store the inference results. And the purple box, we serve the embedding store in the feature store to machine learning applications. I will go through them one by one. So data is critical for machine learning. Without accessing the right data, you cannot get a good model. So Jasper, yeah, it is a gemstone. It's a place where machine learning practitioners can access to different types of medias. So there are a couple of challenges. Firstly, before Jasper, machine learning practitioners need to work with different teams to get access to different kinds of media data. In addition, because of the complexity of asset hierarchy in the studio space, it is not trivial to machine learning practitioners to know which is the best asset to use for their case. Even after you gain the assets, you know how to, which one is the best to use. Machine learning practitioners also need to deal with the unify across different assets in terms of the decoding performance, size, metadata, and general formatting. So what's our solution? We standardize the media assets for machine learning purpose with pre-processing steps. For example, the resolution, the formats, and we also associate metadata with each asset. For example, the size, the frame per second crop parameters, those are commonly used by MediaML algos. We also attach an adequacy score to tell how well an asset matches to the researcher query. Finally, Jasper also provides a unified library that enables machine learning practitioners to access media assets. So come back to this overview picture. Now you have media assets, and you can create a training data set, get the model ready, and now you can start inference on the whole catalog, or we call scoring at this slide. Next, I will talk about how we leverage Metaflow hosting to scale. So this is the inference workflow we saw previously. Each green box presents a compute function, or we call it feature. So it can be a machine learning model or a pure data processing function. So for each feature, we give them a input, we will get an output from it. So for example, the input of the shot segmentation is a video asset, and the output is a list of start and timestamp of the whole movie, of the video shots. And the compute resource required for each feature is different. In this example, you probably can think of shot segmentation is a CPU intensive. And for video embeddings, we need GPU in remote. And for when it comes to the binary classification algos, the computation is lightweight. With Metaflow hosting, we can easily achieve this requirement. Each feature becomes a Metaflow hosting web service. You can specify the compute resource differently and scale them independently. So other than we can specify the compute resource, Metaflow hosting also provide versioning. So you may need to upgrade your model or change your compute function. Metaflow hosting versioning will help the feature owner track which Metaflow hosting is running on which version of the model. In addition, Metaflow hosting provide auto-scaling. For example, when you initially set up your feature, you probably want a backfill on the whole catalog. But later on, you probably just want do the inference on the newly coming movies. So you don't need to worry about the scaling requirements difference. Metaflow hosting will handle this for you. Dependency management is another challenge, especially for Python. But it is critical for machine learning because you do want reproducibility. As well, consistency between the local developed environment and production environment is also important. So that machine learning practitioners don't need to waste their time fight against the inconsistency. Metaflow hosting provide a way to lock your compute environment so that, and the environment can be also shared between your local and remote. Lastly, asynchronous request support is another benefit because to balance the cost and computation time, some MediaML goals will run over 20 minutes sometimes. So the request may time out, but because of the asynchronous request support, a long computation is accepted. So we talk about the media assets, we talk about the scoring cluster, how we leverage Metaflow. I will quickly go through triggering, compute, and feature store. So let me introduce another gemstone, Ember. So Ember is a suite of instructor components that offering triggering, computation orchestration, and feature store. There are a couple of challenges when you apply tons of MediaML algos on the entire Netflix catalog. So it is expensive and time-consuming, especially when machine learning practitioners independently compute identical features against the same asset in their machine learning pipelines. For example, the video shot segmentation is a very common used feature. So a lot of ML algos based on the results. So how can we prevent the duplicate computation and promote the reuse? So we add a storage layer feature store. And the feature store will memorize the features or embeddings tied to media entities to reduce cost and promote reuse. For example, for Stranger Things Season 1, Episode 1, if we finish the shot segmentation computation for that episode, unless there is a new delivery for that episode, or the researchers request a computation on the new version of the model, we are not going to compute that again. So this is mainly because feature store remember the shot segmentation for this episode. And Ember Compute is a layer on top of machine learning inference pipelines. You can imagine in MediaML world, the dependency graph is much complicated than this. Ember Compute will handle the dependency resolution and orchestration the pipelines. So lastly, you also want Ember Compute orchestration, the inference workflow every time a new movie comes in. So previously, we mentioned about Jasper and media and metadata. So Jasper basically stores the snapshots of media metadata. And Ember Trigger will compare two snapshots version of media metadata so that Ember Trigger know, okay, what's the new arrived assets? And Ember Trigger will tell Ember Compute, okay, please compute the, please trigger my inference workflow for the newly arrived assets. So we have triggering compute and we store the embeddings in the feature store. how can we serve the embedding results to the visual search application. So embeddings stored in Feature Store will be replicated into a service called Marken through the Ember replication service. So Marken is a annotation service which support nearest neighbor search. When a text comes in from application, the media understanding platform will construct a annotation query, send it to Marken, and Marken will return the closest matching videos with the metadata back to the application. So yeah, today we briefly talk about the MediaML infrastructure. I also put some reference here. Those are public posts. So if you want to learn more details, please take a look. And this is our MediaML team. Yeah, that's all.
Thank you. Wenbing did a great time with time, so we actually have time for questions. So if you have any questions, please make your way to the mics. Oh, and I wanted to specify as well that all these videos will be posted after the event, so you will have access to them.
Thanks for the great presentation. I have a question about feature importance and the life cycle for features. Do you keep on growing the feature store in Ember, or you decide sometimes to retire some of the features that are expensive to compute and brings marginal improvement to the performance?
Yeah, that's a good question. So like I mentioned, we have versioning, right? We have versioning on features as well. Now we only grows on features, but yeah, this is a good point. We should retire some of the features, for example, the very old versions. Yeah, so to answer your question, we grow in the feature store.
Hello. Yeah.
Hi.
So I'm a big fan of Stranger Things, and
Thank you.
Want to understand like how you did A/B testing, like with what works, what does not work, like in MediaML platform.
Sorry, can you repeat the question?
The question was related to A/B testing for MediaML platform. Like, how do you make sure that what works, what does not work?
Yeah, so yeah, basically we are like serving the embedding results to internal tools. So for A/B testing, yeah, because I'm like more working on the infrastructure side. So yeah, I think we have public posts may answer your question well. Yeah.
Hello.
Yeah.
Hi, my name is Webster. I have a question about, great talk by the way. So I have a question about how do you guys package your models after the models are trained to make sure, you know, like the dependencies in the training environment and everything, they are available in the inference container, let's say, and like the model itself is hermetic, and yeah, how do you
Yeah, so I know, yeah, so Metaflow is what usually used by our machine learning practitioners. They can use Metaflow to have a flow to create the model artifacts. Yeah, usually the models are stored in, you can think of a S3. We have some security packaging on top of S3. So they can directly download their models from the storage layer and download into the inference containers, start the inference.
Got it. I guess the other question I have is when would you decide to trigger maybe a full retraining of the model with like backfill on like existing like, you know, full set of data, because like maybe incremental training may not work well if you only train on like new data, etc.
Yeah, so basically the decision is based on the machine learning practitioners. So our platform is mainly provide the ability so that they can do backfill on the whole catalog in an easier way. Yeah. And yeah, so for after they have a new model, they think, okay, it's time to like backfill the whole catalog. They can like directly trigger the backfill.
Got it. Thank you.
Yeah, thank you.
Thank you. What do you use for this feature store?
Yes. So for feature store, we use, like I mentioned, the object storage. We have a security layer on top of it. And for Marken, as I mentioned, the annotation, we basically copy the data from the object storage into Cassandra clusters for a better searching performance.
Thank you.
Yeah. All right.
Thank you so much, Wenbing.